In section 5.1, we're going to look at random variables. Suppose that we look at some random sampling of students and the number of siblings they have. So we've got, let's see, possibilities of 0, 1, 2, 3, or 4 siblings, and then their frequencies. So this looks a lot like a frequency distribution. Remember, we've done things like this before. So here's our frequency distribution. Our classes are a little bit different. They're just specific values. So we have a frequency distribution here. And remember, we've done stuff with this before where we find additional parts to our table, such as relative frequency. Well, we've done that before and tacked on a whole section of our table called relative frequency by doing things like the following. Well, we would take, to find the relative frequency, we did, let's say, 8 over 40, which got us 0.20. And a lot of times we turn them into percentages, but let's just leave them as a decimal. And then we could do 17 out of 40 for the next one to find its relative frequency, which would be 0.425. And for the next one, it'd be 11 out of 40, which would be 0.275. And for the next one, it'd be 3 out of 40, which is 0.075. And the last one, 1 out of 40, should be 0.025. And remember, if we wanted to double check, these should add up to just about 1. It's probably not perfect, but it should be very close. So now notice that these relative frequencies that we just came up with, that we didn't turn into percentages, we just left as decimals. Remember that this is the same way that we found probabilities back in chapter 4. That is exactly right. So the relative frequencies that we found back in one of the first chapters is the same way that we found probabilities in chapter 4. So instead of calling these relative frequencies now, we want to call them probabilities, P of X's. So we've got these P of X's, and what that now stands for is the probability. So just reading the first one, just to give you an idea, is that the probability of selecting someone with 0 siblings is 0.2. The probability of selecting somebody with 2 siblings is 0.275, and so on and so forth. So let's take a look at this table. So if we were to ignore the frequency part and only look at our classes, and instead of the frequencies here, we look at our relative frequencies, our probabilities here, those two pieces together are what we're going to be using a lot of in this next chapter. These two pieces together are, instead of being called a frequency distribution, are going to be called a probability distribution. So what do we know about probability distributions? Notice, just because they work just like relative frequencies, they have to add up to 1. What else do we know about probabilities? Probabilities have to be between 0 and 1, meaning they can't be negative, and they can't be bigger than 1 or 100%, and they have to add up to 1. So what we're looking at here, because we just have a couple of numbers here that are finite that we can count, is this is called specifically a discrete probability distribution, because there's only a finite number of possibilities. So then what you can start doing, and they'll have you do this in the homework, is once you make a table, is then you can start answering a bunch of questions. So in the first question that we want to ask here is we want to talk about what's the probability of selecting somebody that has at least 3 siblings. At least 3 means 3 or more. So let's talk about that first. So at least 3 siblings means 3 or more, which in our table would be 3 or even 4 siblings. So that means we just take those values and add them up. So it could be that you have either 3 siblings or that you have 4, because we said at least 3. So we can add those up. So our 0.075 is the probability of getting somebody with 3 siblings. And then we want to also add up the probability of choosing somebody with 4 siblings. That's the 0.025 using our table. So now I need to add them up. And let's see what we get. The 0.075 plus the 0.025, and let's see, we end up with 0.1. And that's our final answer and our probability for having selecting somebody that's going to have at least 3 siblings. Let's try one more. Using the same table, let's call this one B. Let's find the probability of selecting a student that will have fewer than 3 siblings. Fewer than 3 means less than 3. So let's go ahead and count those up. So fewer than 3 or less than 3 means you could have 2, 1, or 0. 2, 1, or 0. So that means what we would do is add up all those probabilities. Your probability of having somebody with 2 siblings, 1 sibling, or none. Remember, I'm saying the probability of having 2 siblings, or 1, or none. Keyword is or. That's why I'm adding everything up here. So we'll find the probability of having 2 siblings according to our chart is 0.275. Probability of selecting somebody with 1 sibling is 0.425, and of having none is 0.2. And then all we do is add up all those values. So the 0.275, the 0.425, and the 0.2, which gets us 0.90. Now notice, let's compare our answers from A and B. What do you notice about them? If you look at them together, they add up to 1, and there's a reason why. If you look at part A, which was just your probability of having 3 or 4 siblings, and then if you look at part B was having less than 3, which means 0, 2, or 1, notice that together they make up the entire sample space. So they are complements. Remember, if they're complements, they should be adding up to 1 or 100% of the data. So this does match up and make sense.